Welcome to 2021 question A3. So here we have an image shown of an ammonium ion which is the shape of a regular tetrahedron. Okay, a regular tetrahedron. The nitrogen atom is located at the center of the tetrahedron. So you can see here, here's our nitrogen atom and other atoms there. So nitrogen N is in the center. Okay, and the 4 hydrogen atoms are located in the vertices. So here are 4 hydrogen atoms. Okay, but they are in the position or the vertices of the tetrahedron. Okay, the drawing shows the projections of a regular tetrahedron ABCD and its center N. Determine the dihedral angle between the planes ABC and ABD. So forget about N in the center there, we're just dealing with a tetrahedron now. Okay, and what we're looking at is planes ABC. So ABC is here. Okay, so that's ABC here. Okay, and we've got plane ABD then. ABD. So that plane there as well. So it's 2 surfaces. Now what they're asking us to do is to find the dihedral angle between them. So the dihedral angle is the line that's shared between them. We need to see that as a point view. So here's the line that's shared between them. Okay, so I want to see that line as a point view. First of all, I need to see it as a true length line. So I need to set an auxiliary view looking perpendicular to this line. So slide and set squares. Slide out here, and I have my x1, y1. Okay, and I'm going to slide and set squares now. Slide out, and we're going to bring D. A. B. Okay, so looking here, C and D, they're both on the ground, and so is B. So we've got D, C, B. A then is the height here. I should say we're taking an auxiliary elevation, so we're projecting from plan, creating an auxiliary elevation. Same way from plan we project to an elevation. So get that height from elevation and step it off. So that is A. So AB, that is our true length line. Okay, true length of the line of intersection between these 2 planes. Okay, and here are their plane against. So we're actually looking, both of these planes are kind of resting on top of each other. I've shaded in lightly. We can more see the yellow than we can the other one. Sorry, so I'm looking in this direction. I can see kind of the yellow surface more so than I can the other. So that's why I'm going a little bit heavier here. So next up, I want to see this true length as a point view. So I want to take an auxiliary looking perpendicular to the true length line. So slide and set squares. Here's my x2, y2, x2, y2. I'll project out everything. I'll just slide this. Okay, so project from a plan to an auxiliary elevation to another plan, an auxiliary plan. So I need to go back 2 views to get my distances from my x, y, that's my y2, x2, sorry, y1, x1. So the distance is from my x1, y1 to the plan, because I'm creating a plan view. Same way as when I did my auxiliary here, I went back 2 views and took my distances vertically up from x, y. So heights of D, sorry, the distance to D is this distance here. Let's step it off. Distance to B, which is going to be the same distance as A, which is correct because we're trying to see that line as a point view. So that is going to be A, B, so D, and then finally C. That distance stepped off here, C. So now I have my edge views of all those planes because I have a point view of the line of intersection. So that's a point view. AC, that was yellow, and this was kind of pinky. Okay, so here is my dihedral angle. Between those two planes. Okay, so part A completed. Next, we want to determine the true angle between the lines BN and CN. So, BN, CN. Now, I know looking down here, BN and CN, it might appear as if, you know, looking straight at it, but the reality is there, we can see in my elevation that those lines are actually not just there like that, they're actually kind of sloping upwards towards us. And we can see that there. So what we need to do is we need to get an edge view of this plane, and actually highlight that plane now, colour if I have it. Okay, so we're going to create a plane BNC. Okay, and if I get a true shape of that plane BNC, then I'm going to be able to, so BNC like that, and I know I'm kind of going over where I was already, but that is also BNC. So I'm going to get an edge view of that plane. Now, already this line here, CB, is a true length line because we're looking straight down on top of it and it's resting on the horizontal plane. So I'm going to take sliding set squares and create an XY line over here. Okay, and I'm going to project up to find an edge view of that plane. Because I know that if I have a plane and if I have a point or a line resting on that plane, if I see that line as a point view, I will see the whole plane as an edge. Okay, that's one of our key principles. So, taking my heights then, this is this is a plan I'm projecting to an auxiliary elevation. So, heights N. N is traveling up here, so here is my position of N. B and C are both on the XY line, so here's my X1, Y1, that's B, C, and this is N. So I have an edge view of that plane. Okay, so that's my edge view of that plane. What I want to do is I want to see that as a true shape. So I could take a second auxiliary looking perpendicular to it and taking my distances back from my Y. But just because I've done auxiliaries here already, I'll just do something a little bit different. I'm going to rotate this back onto the horizontal plane. Okay, so that's resting now on the horizontal plane. So when I look down on plan, if I project this back and look down it on plan, okay, I'm looking perpendicular to that edge. So sliding set squares again. Bring this back. Okay, and extend out there. So that is true shape of that surface, BNP, so that's N, and we rotate it down and drop back. So this angle is the true angle. True angle between BN, sorry, true angle of BNC, of angle BNC. Okay, so like I said, if you weren't happy with that, you could also take an auxiliary, so set up an X1, X2, Y2 here, okay, project out, and then you can take your distances from your X1, Y1 back, okay, and might probably have to take a datum, and it might probably actually go off the sheet. So just for the sake of fitting it in, this option, the rotation option, is probably the safer option. Okay, so that was our intersecting planes question on 2021.